Today I want to cover scikit-learn. Well, just not even cover, just introduce scikit-learn, okay? Science something, science kit, what is this? It says machine learning in Python is what it, we'll just get started here and then we can probably spend weeks and weeks on this. Maybe we needed to spend more on pandas. I don't know. There's a lot of panda stuff. And data can't be. I would recommend the other pandas courses that I didn't assign, but
did you put this on the GitHub?
I haven't put anything up yet.
Okay.
Okay. All right. So this is scikit-learn. This is kind of our big powerhouse module that we import into Python for pretty much fitting data to models. And so, you know, kind of your basic one would be like linear regression, and that's what we'll look at today. But then you want to fit, you know, more complicated regression. You want to fit classification, clustering, you know, all of this stuff, right? So this is all stuff probably some of it covered in 102B, a lot of it covered in 101C, but in 101C you're using R. And in this class, we're not going to focus on the math or the theory. This will be in this class, it's very much going to be a black box approach, but that's dangerous, right? You should independently have the probability and stats background to say, oh, this is an appropriate time for linear regression, right? And you had 101A, and you probably learned all of those things. Like when I'm not going to treat you like kids, but you know, so for linear regression, you need to have two numeric variables. When you create the scatter plot, it needs to look linear. Well, after you fit the model, the residuals need to have constant variance throughout. It can't show any kind of patterns. You know, the residuals need to fit a normal distribution centered at 0, things like that. Well, anyway, so you have all of this stuff, and I think it's worthwhile covering some of the basics of how scikit-learn works. Okay, and there's again lots of ways this can go. So I don't know. We'll see how long it goes. So we'll do our regular imports: import NumPy, import pandas, import matplotlib, pyplot. And then for today, we will do from sklearn, import linear underscore model. Now, if you are going to just fit a linear model, there's another package called stats models. And I'm not fluent in either to be able to just do things without looking up the references. But I think that's fine. If you know how to look up a reference and if you can read the reference thing, then you're fine. So there's scikit-learn. There's also stats models. Stats models is a little bit more statistics oriented, and so you know, all the details that R prints out when you fit a linear model and stuff, that kind of stuff will be available in stats models. But you know, in stats models you don't have as wide of a selection of the types of things you can fit like scikit-learn. Okay, but anyway, for today we are just doing from sklearn import linear model. Okay, all of these things you should go through the documentation that's available online. So you go to documentation, and there's all sorts of stuff. Generally, I would just say, okay, we're doing a regression thing, and they have all sorts of stuff, right? Ordinary least squares, ridge regression, lasso. You know, Bayesian, stochastic gradient, all sorts of stuff, right? And then kind of its related things, support vector machines, and these are all okay. So anyway, so yeah, I'm sorry, this is all under supervised learning and general linear models. We'll have the the linear regression. So we're going to just start off looking at ordinary least squares regression, okay? And the kind of the module that we're looking at is from sklearn import linear underscore model, and then we're going to reference linear underscore model dot linear regression. And let's go back to our thing, okay? And so here I'm just generating some random data using NumPy. So I do, np.random.seed, and then we're going to do NumPy random.rand. So this gives me random integers from random uniform from 0 to 1, and I multiply by 10, so I get random numbers between 0 and 10. And then my line is 2 times x minus 1 plus some random noise, okay? And this is just standard normal random noise, so I'm asking for random normal 50. So this is going to add just some things. So basically I got, so the true relationship between x and y is 2x minus 1, and then we've added some noise. And when I plot that, we get this scatter plot. And what we want to do is we want to fit a linear model, okay? All right, and so when we fit a linear model in scikit-learn, what we are going to do is we do, so we've imported linear underscore model, and we're going to do linear underscore model dot linear regression, okay? And here we're going to kind of create an instance of a model. So right now we are saying we are creating this model object, which is just linear model dot linear regression, and we're going to give it the option fit underscore intercept equal to true, which means we want to fit the intercept. And this right now doesn't know what the data is. It hasn't tried to fit anything. It's just saying we are setting up kind of a system, a model, where we're going to try to fit things using linear regression, okay? So if after I define this, if I say print model, let me just go through. Okay, and I say print model, right now it just says this is a linear regression object, or copy x is true, fit intercept is true, and it just has this set. N jobs is equal to 1, normalize equal to false, okay? So, and then if I take a look at my x data, the x, if I say print x, it's currently just a vector of 50 values between 0 and 10, okay? And or a one-dimensional array. And if I ask for the shape of x shape is one-dimensional. It's 50, comma, and there's not a value. It's not a 50 by 1 matrix. It's just a 50, comma, one-dimensional array. Okay, and the inputs for scikit-learn is that the features, your x variables need to be in a matrix. So we need to turn this into a matrix, and the y responses, at least for supervised learning, and in this case a regression thing where our y's are numeric, that's going to be a one-dimensional array. Okay, so I'm going to take x and I'm going to reshape it, and I'm going to call it capital X. Okay, so I take x, I'm going to reshape it to a 50 by 1 matrix, and if I ask what is the shape of capital X now I have a 50 by 1 matrix. Okay, and then now to fit it, so I have our model as defined as this linear regression object. Then I simply call model, and we call the fit method, and we're going to fit x to y. And that's basically it, okay? So I fit it, and if I print the model, it still says this is what it is. But now that I've done this, I can extract the coefficient, okay? So my model coefficient, this is the coefficient for the x, okay? And if we had multiple x's, we would have kind of multiple values here. Okay, but right now it's model.coefficient, and this is my x value. If we want the intercept, we can ask for the intercept, and that's what it prints out. Okay. Then the next thing we might want to do is we might want to kind of like plot the fitted line. Okay. Well, so far is this okay? The way we fit the model is we first define the model as kind of this linear regression thing, and then we call the model and we do model.fit. Okay. And then so let's say I want to fit kind of a linear thing. So I'm going to do we'll do kind of, I'm going to call this prediction x, and this I'm going to do linear spaced values, and we'll go from I can just do 0 to 10 and what's the default going to be? I should ask shape of prediction x. Whoops, got my R mentality. Okay, so 50 values. So we want to kind of reshape this to 50 by 1 matrix. So we're going to have a prediction underscore x. We're going to do reshape to 50 comma 1. Okay, so this is, oops, and I should call this prediction underscore x. So we'll just rename this. I could have also just done linear space and do reshape 50 comma 1. Okay, you can kind of link these methods one after another. Okay, and then now that we have our model, I can do model.predict, and I would feed in prediction underscore x. Okay, and so if I do that, these are kind of all the values that it predicts, which seems good to me, but so I'm basically creating kind of a vector of values. It's basically grid approximation with 50 values here, and then if we wanted to add this, I would do so I think I gotta call back PLT. Can I just take the exact same thing? I don't know. All right, I think because I've already, we're gonna do PLT.show here. And then here I got plt.scatter, and then we're going to add plt plot, and we want to plot prediction underscore prediction x comma our predicted values here, model.predict. I guess I'm making the computer recalculate these things, and then we can say color equals red, and that should be it, plt.show. Let's try this out. Okay, and so there is our kind of our fitted line to the thing there. So it's just a matter of fitting, you fit x to the y, so you initiate the model. You do model back here. We define the model as a linear regression thing. Then we fit the model to our x and y values, and then we use the model.predict to create predictions based on a new matrix of x values. Okay. If we wanted to kind of calculate residuals, we can do that manually by asking what's the difference between the prediction for our current x's and the actual values, right? Let's see, let me just see what this. So let me do model dot and coefficients. Get parameters. No. Okay. So so I'm going to call this so the residuals will be equal to model.predict, and we're going to take in our x vector, and we got to do basically our y minus our predictions, right? All right, and then we can see, we can print the residuals. I don't know if that's exciting. np.mean residuals, what should this be? Should be on the order of 0, and it is. We can ask for plt.hist residuals. What we should see is something that looks kind of like normal distribution, which I guess more or less kind of is. Of course, because it's only 50 values, so it doesn't look too bad. And then we can do plt.plot, and we can plot the x values against the residuals. Oops. Okay, and this looks like no pattern in the residuals. So all of this seems okay so far. All right, so that's kind of like simple linear regression. Let's say we want to do something a little bit more interesting, like with an actual data set. So let's look at the, there's a Boston housing data set. All right, so from here, we're going to, so scikit-learn, sklearn has some data sets. And you can always look up sklearn data sets. And there is Boston, iris, diabetes, digits, linear, I don't know what this, something, okay? Different toy data sets, some sample images and stuff, okay. So you can always, everything you can look up. All right, so but from the data sets, we are going to import load underscore Boston, and then we will call Boston load underscore Boston. So we're going to load this up. Let's take a look. Okay, and we can just do boston.head. See, wait, sorry, it's not a pandas thing, right? If I do type Boston, this is what we have. So it's Boston is actually a dictionary. So you have to we have to look up Boston.keys. I'm sorry. Okay, and we have the data, the target, the feature names, and the description here. So we can do Boston.data, and let me just do Boston.data.shape. Okay, so we have 506 rows, 13. Okay, so the so as far as the scikit-learn data sets, so Boston is a dictionary. Okay, the x variables are in data, and the y values are in target. Okay, and so boston.data.shape, this is the X matrix, which has 506 rows, 13 columns, and boston.target.shape, this is kind of the one-dimensional target y values. Okay, the feature names are going to be the names of the kind of the 13 columns here. So we can do let's do print boston.feature names. Okay, so these are going to be the names of the feature x variables, the names of the x variables, and then we can ask boston.description, and this is our data dictionary. So this is how not all not to say all data sets are like this, but as far as scikit-learn, which comes with its kind of toy data sets, will be we'll have the data dictionary kind of like this. Okay, so here we've got 506 values, 13 numeric and categorical predictors. Okay, the median value is the target. So this is going to be, if I remember this data set correctly, this is, this information is no longer there. But back in the, I want to say, 70s, 80s, they went to Boston and they looked at these neighborhoods. There was like 506 neighborhoods, and they said, what is the median price of a home in this neighborhood? And then they looked at certain attributes of that neighborhood. You know, they said, what's the crime rate in this neighborhood or town? You know, what proportion is zoned for this, and what proportion, you know, all sorts of stuff. Okay, and we were curious what kind of stuff affects the median value of our Boston thing. Okay, so so what we want to do is, I think what could be helpful is if we turn this into a pandas data frame rather than dealing with a dictionary. So not dictionary. Type, if I ask NumPy array. So if I ask what's the Boston data, it's a NumPy array, which is fine, but I'm going to go ahead and turn this into a pandas data frame. Okay, so we will convert to pandas data frame, and so we'll define Boston as pandas.dataframe of our boston.data. Okay, so we're going to take our NumPy array and just make it a data frame. And let's just print the head of boston.head. Okay, and so this is what we have. We've got 13 variables indexed from 0 to 12, and that's fine. Probably what we want to do is we want to change the names of our columns to these feature names. So they nicely exist for us. So we're going to do boston.columns is equal to so boss.columns is equal to boston.feature_names. So boston.feature names is this this list, or that array of names, and we'll take that. And so now if I ask for the head of Boston, okay, so that looks better. Okay. All right, and then maybe we'll tack. So we got Boston.target. Again, this is, let me just do kind of our first 10 values. Okay, these are the prices that we are trying to target. Maybe we'll add that as a column here. Okay. Okay, so we will add the array of values to the Boston.data frame. So we'll do Boston, and then we can just create a new new column called price, and we will just throw in the data frame, right? Throw in the array into this, okay? And so if we ask for Boston.head, okay, so now we have price thrown in there as an extra column. Okay, so this is our entire data set. So what we have to do is we've got to so we're going to create, I don't know, we'll call this Boston model. This will be from scikit-learn. What did we do? We're going to do linear. What did we import? We imported linear underscore model. So we will do linear underscore model dot linear regression. I think this is fine. I don't know if we want, maybe we want an intercept or not. We'll just define that at this moment. And then we're going to create our X matrix. So this will just be Boston, but everything but the price vector. So we're going to do Boston.loc, and we want, how do we do this? Will this work? So we're going to take all the rows, and we want from prim to lstat. We just x.head. Okay, that's what we want. Okay, so that's going to be our x, and then we'll fit Boston to our the prices. Okay, so we'll do our target, but again, you know, so we threw the target in here, but again, if I just subset, so this was, maybe this was silly, but if I just subset price, the, oops, this is still a data frame, right? And it needs to be a, so if I say type here, I'm sorry, this it's a series, and what we need is a data frame. So I think it still makes sense to just use Boston.target, or if we wanted to, we can throw it back into kind of a NumPy array. All right, let me see. Okay, so we will do our model, Boston model dot fit, and what we want to fit is we're going to take our x and we're going to go for Boston dot target, and we'll do that, and then we can ask for Bos model dot coefficients. Okay, so now we have a bunch of coefficients here. Let me see. We can. It's hard to it's hard to plot something like this, but we can ask for boss model.predict, and we can ask for our predictions on X, right? And so here we would get an array of kind of 506 values. So these are, I'll call this Y hat. And we can create a plot comparing Boston.target versus our Y hats, right? So we can compare the true values versus the fitted values, and we'll throw in plt.plot and plt.show. Okay, so this is predicting. When we plot this, do we normally put actual versus predicted, or predicted along the X and actual on the Y? Probably. I don't know if it matters. Okay. And we'll do plt.xlabel is predicted, plt.ylabel. Okay, so we got predicted. This is what we predicted. The actual values are up here. Okay. We can calculate our residuals. So residuals will be equal to Boston.target minus Y hat. Okay, and then we can plot those. We can do plt.plot, and we want to compare. What do we normally compare? The predicted versus the residuals? Kind of? Okay, we'll do that. Y hat versus the residuals, and we want to, and we'll do plt.xlabel is the predicted value, plt.ylabel is the residual, and we'll ask for it to plot this. Okay, so I don't know what's going on with these data points, right? Like, so this stuff seems okay over here. This over here, I don't know what's up with these data points, right? So we've got some certain counties or certain neighborhoods that all have values of 50, and it's probably worth looking into, like, what's up with those, right? So so as far as price, what is Boston column price? And we can ask for np.max 50, and we can ask, let's subset this. So we'll ask Boston.location, and we want where price is equal to 50. And let's just get all the columns there, and let's just print this out and let's see what this looks like. All right, so we have, let's maybe, for some, Jupyter, when you don't say print, it actually prints it a little bit nicer. So I don't know what the deal is with these places, right? Like, they probably should be different, but for whatever reason, their price is equal to 50. Maybe, if we look at the dictionary, maybe there's a good explanation for why price is equal to 50. No. And Boston housing data, is this 506? Does it say anything about? you know, like because this data set's like one of the toy datas, like if you wanted like real Boston housing data, it's like it's hard to actually find true Boston housing data because everything you search is now this toy data set.
That's funny.
But let's see, why 50? Does anybody? All right, I'm trying to figure out like why the median value is 50 because it seems too. It seems weird. Like it doesn't. Like everything else has like a decimal value. You know, 24.0, 21.6, 34.7, and then 50. It's just weird, right? Maybe I should throw those away. I don't know. Like, I don't know. Okay. Anyway, let me see. What else should we do? We probably want to do some kind of forward fitting in terms of parameter selection, right? Because right now I just threw everything into this. Let me see. I gotta find. Let's see, what else? Okay, let me see. Does SK, how do we get, let me just look up what my options are here. So we fit the Boston model. Let's see what things we can get from Boston model. Boston model dot, and I'm gonna hit did I type something wrong? Oh, boss model. Okay. Boss model tab. Okay. Copy X, fit intercept, get parameters, intercept, end jobs, normalize, predict, rank, score, singular, set parameters. What are other things that we can do? I want to get make predictions, train the model, the coefficients, plot outputs, explain variance score, R2 score, mean squared error. Okay, so I guess we can call mean squared error and R2 score. I want like the ANOVA table. Let me see. sklearn ANOVA table. sklearn.feature selection. Okay. You know what? I'm sorry, I didn't. This was as far as I had planned, and so now that I'm thinking about this, I'm going back into my head about like what you learn in 101A, and we have things like model selection and which things, and I haven't looked those up. So I guess I'll have a little bit of homework for myself to look those up, and then I'll include kind of some of the steps, necessary steps for deciding on which variables to select and keep. But this is kind of just like the generic model where you throw the entire data set into the thing, which is probably not the best strategy, but at least you might get an idea of whether a linear model makes sense, which as far as making our predictions and the actuals, with the exception of these that all have the same value, it seems fairly okay. Some stuff down here and some on the high end maybe may not fit the linear trend, but at least things in the middle, it does seem like something is doing a decent job of predicting the price for these things. But again, things to look into would be why are there all of those 50s, and then how can we kind of prune our model to be a little bit better. So, but anyway, this is just kind of linear regression. The other option is to look up stats models, linear regression, which offers kind of a lot more of those traditional linear regression tools that we're kind of more familiar with in R. But I'll finish filling out this this notebook, and I'll post that online. Okay. Are there any questions before we wrap up for today? So I'm planning on having a short quiz on Wednesday, and I'll try to make it. One suggestion was to make it multiple choice. So this is going to be hard for me because I don't know what good fake answers would be, but I'll make it. I'll try to make a multiple choice thing, and then.
No, don't do that.
And then and it'll cover the plotting stuff. Okay, so we'll have that. What's that?
We base it mainly off your notebooks because a lot of plotting things are different.
You've just made this hard on yourself.
Oh man, I don't know. Okay. Everything's valid. What do you mean by they're different?
The content.
I prefer your way. That's how I do it too. But
Yeah, data can just kind of
Okay. All right.
be more fundamental.
I'll.
Yours is more pragmatic.
I don't. All right. Well, I would say if I had to pick one, I would say the notebooks. But yeah, we'll go. Yeah.
So for,
Are you gonna post like the C-board notes?
Oh yes. I'm sorry. I'm behind on getting all the notes posted. Yeah, I'll post the Seaborn notes.
okay.
Oh,